Welcome to the module on system boundaries. So, this is the steps in life cycle assessment, and we are going through the scoping phase of LCA. We have already seen the first three steps for scoping, which is the identifying of options to model, functional unit selection, and choice of impact categories, which also affects the method of impact assessment later in the LCA steps. Today we will talk about system boundaries and types of LCAs that are determined by the goals, such as accounting versus change oriented, which is also known as consequential. We will also quickly overview about the process, EIO and hybrid LCA. The next thing is cutoff criteria and allocation. Getting started with considerations in selection of system boundaries. There are four main things that we think about when we are thinking about the system boundaries in a LCA study. The first thing is technical system versus natural system. Second is the geographical boundary. Third is the time boundaries, where we are interested in the temporal scale. And then the fourth, which is very important, is boundaries within technical system. When we talk about boundaries within technical system, it determines how and how many processes we are including and how we are collecting data for it. Of course, boundaries within technical system is also affected by your goal of the study. So, it can be an attributional or a consequential LCA. And next, also the allocation methods. If in your system boundary you have other product life cycles also part of the process for the product manufacturing that you are studying, then we need to think about allocation issues. So, one by one we will go through details of all of these considerations that are needed when you are drawing the system boundary in the scoping phase of your life cycle assessment. Okay, so the first consideration, which is technical versus natural system. When we are thinking about this, we think about where the cradle of the product is and where the grave is. When we talk about cradle, cradle means where the raw materials are being extracted, which is where the natural boundary between the technical system and natural system occurs. And the grave is the final disposal of the end product or the end of the life product, or also the emissions and waste that are kind of going into the environment. So, here we are identifying the limits where the system is interacting with the natural system. It could be where the emissions are going, or it could be where the end of life product is being disposed. It is important to see how technical systems interact with environmental system, because one of the key goals of LCA study is to assess the environmental impacts of LCA of the product under considerations. Systems that are directly human controlled or something that we can control, such as the manufacturing process or recycling process, those are mostly identified as technical systems. So, once we have this idea, we can draw system boundaries that identify the points of interaction of our product life cycles with the environmental systems. Some example of technical versus natural consideration. If you have any non-renewable resource in the product life cycle, for example, let us consider production of oil. So, cradle is where the oil is extracted. So, it is the extraction process, and grave could be throughout the system where the emissions and waste are disposed to the environment. It can also be the end use of the oil itself, which could be in the car, or it could be in any other production process itself. When we are thinking about renewable resources, it becomes a little challenging to delineate between the natural and environmental system, natural and technical system, because we have a constant flow of services from the ecological system. We will later on in the course also go through the ecologically based life cycle assessment that expands the system boundary to include ecosystems. But for now, we will focus on treating these renewable resources as fund resources or flow resources. So, the fund resources are something that are static or forms the capital that is an input to the product life cycle, something like land or forest biomass, because it is there for a longer period of time and it is being reused again and again. Flow resources are something that is being consumed during the production and it is in flow or in flux during the manufacturing process. Something like energy flow or water flow, these are flow resources. So when you are thinking about technical versus natural systems, in non-renewable versus renewable, we can think about where the interaction is happening, whether it is a fund resource or a flow resource. The treatment of these two in the product life cycle is a little different, because fund resources continue to be used for a longer period of time. So there is a temporal variation aspect in consideration of those resources. But if you have a flow resource, it is being consumed mostly in the time duration of the manufacturing of the product. Hence, it does not have that much temporal variation as compared to the fund resources in consideration for the product life cycle. The second consideration when we think about the scoping or the system boundary for our life cycle analysis is the geographical consideration. Geographical consideration is important because lot of the stages of our life cycle of the product may not be located in the same location. The regional variation or the geographical variation is very crucial for LCA, and it is different in different cases. Hence, a same product being manufactured in location A versus B can be different. For example, if you have a product being manufactured in location A but used and discarded in location B, you would want to consider that spatial variation in the life cycle of the product. However, it is very difficult to obtain this information, and it has been one of the major critical limitation for validation of LCA studies. But if you are working with a company and you can gather that data, consideration of the geographical aspect is very important and will be more accurate in decision making if you have such information. Hence, while defining system boundaries, you will need to consider how the geographical location of a particular life cycle stage will affect your decision making or answer to the question in goal. It is also very important in the environmental impact, because some of the places the emissions may be the flora and fauna may be very sensitive to the emissions that are coming out of your manufacturing process. Consideration 3 is time. So this aspect is mainly important for consequential LCA. We will see what consequential LCA is in a bit. But it is important because if you study a change in consequential LCA, it is important to understand what time frame that change would be effective. Most of the attributional LCAs that are done are mostly retrospective, considering that certain impacts can be attributed to use of certain product or processes without actually considering the temporal aspect of that impact is what is done in attributional LCA. However, temporal considerations are complex and they are very rarely studied. There is an increased emphasis on doing dynamic LCAs, but it needs temporal data, which is generally not available. But now with the advent of data science and AI, maybe we can simulate such data to do dynamic LCAs. On the other hand, we also do life cycle cost analysis, which is a little different than the typical LCA, which focuses mostly on the environmental aspect. In life cycle cost analysis, we do consider the temporal aspect or time value of money, which comes from the traditional economic compound interest or simple interest formulae. So we will look at the life cycle cost analysis when we get to that topic. However, in brief, you would want to identify the timestamp of the data that you are collecting so that you know at what time the manufacturing process is being reflected in the data, and then you can report that. However, consideration of temporal aspect is a more complex matter in LCA consideration. Consideration 4 is boundaries within technical system. So this is where we will focus a lot in this course. We will go through the computational structure of process LCA and economic input output LCA. What is process LCA? Process LCA is simply stated focuses on the most important processes, and we use the detailed information for each process in the calculation of the life cycle environmental or economic impact for that particular product life cycle. Processes are based on the manufacturing processes or chemical processes or any other processes that are involved. However, it does not take into account all the other upstream or downstream process. Hence, it is not comprehensive. The next one is economic input output LCA. Since in process LCA, we need to focus and select few processes that are going to be within our system boundary for our study. But that may leave out some of the important impacts. Hence, the subjectiveness of selection of most important processes is overcome by considering the entire economy. In this aspect, the whole economy that is involved in the manufacturing of a product or a process is considered. Here, we rely on the macroeconomic input-output model, and this type of LCA is known as economic input-output LCA. Later in the lectures, we will definitely go through the computational structure of the economic input-output model and how these models are used for computing life cycle impact of any product or process in the economy. The challenge with economic input-output LCA, as we will see when we go into detail, is that it is aggregated and coarse. It is less detailed than the process LCA. So, of course, process LCA has the advantage of being more detailed, more accurate, while economic input-output LCA has the advantage of being more comprehensive. To overcome the disadvantages of each of these, we combine this into what we call as hybrid LCA, and it is combined process LCA and EIO LCA. We will see one example of a tiered hybrid LCA, which basically states that for the most important processes, we consider process LCA, and for the rest of the processes, we consider an economic input-output LCA. I will demonstrate a simple example of hybrid LCA to show how EIO LCA and process LCA are combined. This is an example of showing what are the differences in system boundary for process, EIO and hybrid LCA. The figure that you are looking shows an example of manufacturing of algal biodiesel. If you think about the life cycle stages of algal biodiesel, it starts with the cultivation phase where you have the cultivation of algae in a pond or in a photobioreactor. Then there is a harvesting and drying stage. Then there is lipid extraction, which is a chemical process. Then we have a co-product upgrading, which is enhancing of the product for use. Then there is transportation stage, and at the end we have the fuel production, but there are also some co-products that are being made such as electricity and heat that can be used. So, this is an example of a simple process LCA. If you think about if you have to do a process LCA for algal biodiesel, your system boundary will connect all these processes from starting from the cultivation to the stage of transportation and final product delivery. This will be called as a cradle to gate LCA, and this is an example of process LCA system boundary. However, we can see that this process requires lot of upstream inputs such as urea input, such as superphosphate, other water, potassium chloride, nitrogen hexane, aluminum sulfate. All of these chemicals are inputs, and since these chemicals also are manufactured through some processes, these will also entail some environmental impact for the life cycle of algal biodiesel production. Hence, we also want to include the impact of these upstream processes that manufacture these chemicals. In order to not go into detail for manufacturing of all these processes, what we do is that we consider those as part of some economic sector that is providing these chemical inputs to the processes involved in the algal biodiesel manufacturing. So, that is part of our economy, and that forms the part of our economic input output LCA. So, we will see an example where we see that all the upstream processes can be considered to be coming from the economy, and we will see the computational model how we calculate the impact from the economy. And when we connect both of these together, we join in a tiered hybrid mode, then we call it an hybrid LCA. So, here I have shown you the system boundary selection for process LCA, EIO LCA and hybrid LCA, and what I will do as we go along the course is go through the computational structure for process LCA calculation, EIO LCA calculation and hybrid LCA, and we will also do some examples that will help you understand the computation better. Next, selection of system boundary also depends on the type of LCA, such as attributional LCA versus consequential LCA. That is defined in UNEP-CITAC, which is our United Nations Environmental Program and Society of Environmental Toxicology and Chemistry. The two models, attributional LCA versus consequential LCA, answer different questions. So, based on goal of your goal that you define in your goal phase of LCA, your system boundary or system model will change, and we will see an example how it changes. What is attributional LCA? Attributional LCA, in the most straightforward way to say, is that it is mostly attributing the impact of different process in the steps for manufacturing of your product. So, you can read the definition here. In this LCA, inputs and outputs are modeled according to the functional unit of the product system that we are studying, and we link and partition the unit process of the system according to a normative rule. And by normative rule, we mean that we are going to allocate the impact of each of the processes involved, attribute that to the production of the product that we are looking at. So, that is the simple attributional LCA. Most LCA studies that are published are attributional in nature, unless they specifically mention that it is a consequential LCA. Next is the consequential LCA. What is consequential LCA? This one is more focused on decision making. This is where we are kind of interested in seeing what are the impacts of me making a change in the production system, whether it increases or reduces the environmental impact for that product system. So, reading through the definition, in this LCA, activities in a product system are linked so that activities are included in the product system only to the extent that they are expected to change. So, a key point here you can see is that it is the expected to change is what is very important. We only include those processes in our system boundary for a consequential LCA which are expected to change. For example, if we are changing the energy process, if in the energy process we are changing the actual energy production, we will include, but if we are not changing the transmission and distribution, we will not include that in our consequential LCA process. So, here the focus is that if we have a change in demand of the product and we are making a change in a major part of the system, then we include that in the LCA, otherwise we don't. So, we will go through the example of consequential LCA. So, what are the characteristics of attributional and consequential LCA? In terms of system boundaries, the accounting or the attributional LCA focuses on additivity or completeness. So, we are more focused that we include all the processes which are important for in process LCA, and we attribute that impact that is associated with production of the product in our focus. When we are thinking of change oriented or consequential, we are only thinking of the parts of system affected. For example, if we are changing our product life cycle in a way that we are sourcing a different raw material, then we only focus on the raw material manufacturing process that is being changed. There is another thing which is allocation process. So, we will go through allocation next in a few minutes, but allocation process is reflecting causes of change or partitioning. So, causes of system or partitioning, which is basically saying what part of my system that is included is contributing to the manufacturing of that particular product. And in the case of consequential LCA, we are reflecting effects of change. So, if I am changing some life cycle stages in the life cycle of the product, how is that change affecting the overall system or any other system? So, here we will go through system expansion, or how do we expand the system or give credits to the system. So, we will also see an example of allocation for system expansion. The choice of data mostly in attributional LCA is average, and for change oriented it is marginal. And by marginal we mean that it is mostly the part that is affected and that is being changed that we include. System subdivision is another thing. So, in accounting we do not have any system subdivision characteristic, but when we go to the change oriented or consequential, we have foreground and background processes. So, foreground processes are the one that are actually being affected due to the change that we are proposing in the life cycle of the system, and background are the ones that are not being affected. So, once you do that system subdivision, it is very easy to delineate which one would be part of your study and which one will not be part of your system boundary. So, let us quickly do a thinking activity, go back to the attributional LCA and consequential LCA definition, and as we said that based on the goal of LCA, it is an either attributional or consequential, and based on that your system boundary will be changed. So, what you need to do is you need to identify the system boundary for the paper cup LCA in following scenario. So, we already in the past have seen the system boundary for paper cup LCA, two different system boundaries. Here the first goal, the first LCA analyst wants to identify the life cycle environmental impact of single use paper cup. That is what they want to do. The second analyst has a more specific goal. What they want to do is they want to identify the impact of changing the source of paper for paper cup manufacturing company. So, go ahead and draw the system boundary for these two LCAs or the goals defined, and then we will quickly go through the answers. So, the first goal, which is where the analyst just wants to identify the life cycle environmental impact of single use paper cup, is an attributional LCA, because all we need to do is identify the key processes and attribute the impact of those processes to the single use paper cup manufacturing. In the second one, the analyst actually wants to identify what happens if they change the source of paper for paper cup manufacturing, and this is an consequential LCA because they want to identify the impact of that change, which is what are the consequences of this change. So, let us see what the example system boundary will look like. For the attributional LCA, it is very simple. We start with pulp extraction, paper manufacturing, then it goes to paper cup manufacturing, it can go to paper cup use and paper cup disposal. That is the cradle to grave attributional LCA. In the consequential LCA, what is happening is that we are interested in the change in the paper source. So, instead of your pulp extraction 1 or paper manufacturing 1 process, it is being replaced by pulp extraction 2 and paper manufacturing 2. Here, when we have to study the impact of that change, we do not need to consider the background processes because there is nothing happening to the background process. Paper cup manufacturing, paper cup use and paper cup disposal, those life cycle stages are not affected. All you need to do is actually look at the foreground processes, which is the pulp extraction and the paper manufacturing, and compare the two sources to understand the impact in terms of total greenhouse gas emissions or water use or other impact categories that you need to change. So, you can see that in attributional versus consequential LCA, your system boundaries will be very different. Your system boundary in consequential LCA is smaller here because we are just looking at impact of changing the source of the paper, but in attributional LCA, we are considering the full cradle to gate. So, based on what your goal is of your LCA, your system boundary for these two cases is going to be different. I hope this is very clear to you all. So, whenever you think about your goal, based on that attributional versus consequential, you can decide your system boundary. Okay. Next, we will come to cutoff criteria. So, Why do we need cutoff criteria? If you think about our LCA and system boundaries, we can keep on adding more and more processes, right? So, for example, if we are looking at manufacturing steel cup, so we'll identify all the things that we need to manufacture a steel cup. For example, we need raw steel input, we need energy input, we need transportation support, we probably need water for the plant for cooling requirements, there is labor input, there is facilities, there are also infrastructure such as lathe machines, molding tools, finishing tools. We perhaps also need computational power if it is an automated manufacturing plant. For that we need semiconductors, we also need plastic for molding, and so on and so forth. So, you can think that we can continue to increase and expand our system boundary by including more and more upstream and downstream processes for our LCA. And if you are doing a process LCA, that means we are going to collect a lot of data and we will need information about a lot of these processes which are generally not available. So, the question is that where do you stop in your process LCA? For that, we use what we call as cutoff criteria. So, what cutoff criteria is a criterion that should be used to decide when a part of the life cycle may be cut off, which literally means that we will ignore that particular processes in the process LCA that we do. One example could be that if we have certain parts of the life cycle that may be negligible compared to the rest of the life cycle. An example can be that if you have a very clean process that is not emitting any emissions and your goal is to understand the emissions life cycle for your product, you can ignore that process because that is not contributing that much to the environmental impact that you are focused on. There can also be irrelevant for your LCA. For example, in our consequential LCA, if there are life cycle stages that are not impacted by the change, they can be safely left out. So, that can be your background processes and those are not going to be included. So, what is the quantitative way of doing this? The quantitative way of doing this is that we set a cutoff rule that are typically expressed in terms of mass. For example, we can say that the LCA study will use or include at least 95% of the total mass of inputs and no inputs shall be excluded that individually contributes 1% or more of the mass. So, what this means is that if you have information on all the different processes and you see that there are some processes that are contributing less than 1% of input to your main manufacturing process, then you can say that this is something that will be insignificant in terms of environmental impact and you will be ignoring that. You can also use emissions as criteria or whatever your interest of study is. It can be water input, it can be land requirement, it can be any other resource that is your requirement. The 95%, you can also use 99%, you can use 90%. Based on that cutoff, you will be stating your result. But it is very important for you to state your cutoff rule when you are including a certain process or excluding a certain process. Next, we will go through the allocation rules which are very important when we are partitioning or doing system expansion in case of system boundary selection.